Hello, everyone. Thank you for joining us today. In this webinar, Fluor Fellow Mike Holcomb will discuss the latest strategies and risks to implementing effective security measures. Michael will provide valuable insights and actionable advice to help you safeguard your company's critical infrastructure. To set the stage for today's webinar, with the health, safety, and environmental topic, please join me in welcoming Banna Cord.
Thank you, Sabrina. Practicing cyber hygiene involves following a set of processes to ensure a desired level of security is maintained. The health, safety, and environmental topic is on cyber hygiene with the Center for Internet Security's Critical Security Controls, or for short, they're commonly referred to as the CIS controls. The information security industry today has no shortage of regulations, guidelines, best practices, opinions, and even frameworks. Many of these document bodies seem to overlap, and software and hardware systems are not secure by default. The seeming competing guidance can lead to confusion in how best to manage an organization's cybersecurity posture. This is where the CIS controls can help. CIS controls are created and maintained by expert contributors across a wide variety of industries and government agencies. The focus is to provide something applicable to private and public sector, as well as any sized organization. Currently, in its 8th version, the list has matured from a simple sequence of maturity steps to now prioritizing implementation. Previously, these were called the CIS Top 20, but recently, CIS has shifted the product to something more meaningful. As opposed to being a simple progressive list of tasks to grow in cyber hygiene, version 8 has refined these controls to 18 activities that group together specific actions an organization should take to implement the control. A control uses high-level language to describe the activity. A few examples include account management, continuous vulnerability management, and inventory control of enterprise assets. The specific action to take is called a safeguard, and there are between 5 and 14 safeguards for each control. If we dig into account management and look at its safeguards, the first two are establish and maintain an inventory of accounts, and the second is use unique passwords. Each safeguard is mapped to NIST Cybersecurity Framework, or the CSF, for the common language of identify, protect, detect, respond, and recover. Depending on the size of your organization or its mission, you may not need to implement all the controls or safeguards. This is where implementation groups come into play. Implementation groups are roughly aligned with the size of an organization. Small businesses will most likely fall into Implementation Group 1. Medium to large organizations may find that Implementation Group 2 is sized to meet their regulatory and compliance needs. And Implementation Group 3 covers large enterprises. Each higher-level implementation group includes all the safeguards of the lower groups. This concludes our HSE topic, and with that, I'll turn it over to you, Mike. Thank you.
And thanks, Ben, and thanks for the great overview on the critical security controls. And thank you to everyone for taking the time to attend today's session. This is definitely a subject I'm very passionate about when talking about securing control system environments, because it's not just about securing computers and systems from cyber attacks, but it's really about protecting the world around us, that we, our families, our friends, the communities we live in. And so it's more than just keeping a computer safe from malware or ransomware. So with that said, I want to go ahead and jump right into it. So before we really get started, I wanted to make sure when we talk about control systems in general, or OT, or sometimes we say ICS, so we talk about operational technology or industrial control systems, we use the terms for this presentation and in general interchangeably. So we'll probably say OT the most in the presentation, but again, we're really meaning the same thing. But before we do get into the the security conversation, I want to take a brief moment just to level set and look at what we mean when we say ICS or OT, and which, while there's similarities between OT and IT, there's definitely some similarities. They're also very, very different. And so IT networks is where we typically have our office or back office activity, where we have our employees sitting at our computers or laptops or reading email, we're browsing the internet, maybe we're doing research for work, maybe we're doing online shopping, we're reading the news. The idea is we're interacting with the internet. And we have to remember the great thing about the internet is that it connects us to everyone. And the bad thing about the internet is that it connects everyone to us, which is it's the good and the bad and everyone in between. Now, on the OT side of the house, this is where we have the network and the systems or the control systems that provide some specific function to running an industrial facility, such as a power plant, petrochemical facility, subways, mining operations, hospitals. And so if I have a power plant, right, it's designed to sit there and generate power. If I have a manufacturing facility like one to create insulin injections, right? We have that plant to create insulin. And so, again, while there's some commonalities between the two, they're still very different, and how we secure them can be very different. And each of the OT networks has their own special requirements. So each OT network itself can be its own special snowflake and can have its own needs, because each facility has its own physics and how it operates in the world. And so you might be able to imagine that you have a power plant that it does have different needs than, let's say, an offshore oil rig, which has different needs from an open pit gold mine versus another project and another project, and so on and so forth. So often both of these environments are connected together for business purposes to allow them to communicate and share information, which actually introduces a significant amount of risk to the OT environment from the IT side of the house. So that's where why we're here today, is to talk about how we can work to protect the OT networks, especially those that support critical infrastructure that the world depends on. And real quickly, I wanted to highlight the three primary areas of concern that we have in OT environments. So our primary focus is around physical security or safety. We're looking at making sure that physical harm or there's a potential for loss of life, right, doesn't come to fruition in our environments. And we want to make sure that the personnel that are at the facility are safe and they go home at the end of the day. Secondly, we can talk about the environmental impact. So I always think what if I have a petrochemical facility and if there was an explosion that releases toxic gas? We'd have significant harm to the environment for potentially miles or kilometers around that facility. We'll take the environmental impact seriously, and then we also look at, of course, loss of production. So we want to make sure that that facility, whatever it was designed to do, stays up and running, right? It's producing that X factor that it was designed and engineered to do. So if I have a power plant, I want to make sure that the power plant stays up and running, continually generating power, because it's not really a matter of question of what if the plant goes down for half an hour and we're not generating power for that long. And most of us can live without power for an hour. But what if that stretches out into a couple hours or 24 hours, or a day becomes then multiple days, or days can potentially become months? So that's where we can have these extreme circumstances and consequences as losses get extended out over time and the impact just increases exponentially. It's just not a matter of making sure we're generating power to make money and build clients based off of their energy utilization. But it's really about ensuring that we have lives that are uninterrupted, right? That we allow children to go to school and get people to work, and we can go home at the end of the day and we can flip on that light switch and the lights come on and we're able to make dinner. We can sit and watch TV and we can get back on our computers and get back out to the internet. But we start looking at, again, an impact to how we live our lives. And without those things, if we didn't have power for days or months at a time, what would the impact to us and the world around us really be? So that's really what we're talking about in the presentation today, is protecting the world around us as we know it. So now we've talked real quickly about this idea of the importance of OT cybersecurity and why we're here for this conversation. I want to take a quick moment to look at who we're protecting these environments from. So the ultimate problem that I see for most OT environments is that a lot of owners and operators today still don't see that they don't see themselves as targets. So if they don't see themselves as targets, there's a less focus on security and protecting these networks. And granted, this is changing and it's getting better every day, undoubtedly, but it's a very slow process as well. And at the same time, not only do we have environments where they're not necessarily seeing themselves as targets, or they're just really starting their cybersecurity programs. And then, we look at the number of attacks against OT environments. They're doubling, tripling year after year. And in some more sensitive environments, they're going up 20, 30%, 20 times, 30 times each year. And so there are significant increases in the number of attacks. And not only is it a number of attacks, but it's also the different types of attackers that are targeting OT environments and critical infrastructure. Because 2 years ago, we used to only talk about, realistically, it was the nation states that were targeting these environments, right? Russia, China, the United States, right? It's the nation states that were targeting these environments. And that's just not so any longer. We saw that highlighted with the colonial breach incident, realistically, about 2 years ago at this point, where it wasn't a nation state that took down the largest pipeline in the United States for 10 days. It was a common ransomware group that was trying to infect any just old computer system in an IT network around the world to generate a couple dollars, right? For them, it was all about making money. It wasn't industrial or espionage. And they were just looking at infecting some computers and making some money and being done for the day. Again, because that IT environment was impacted, that it ended up resulting in Colonial Pipeline taking that pipeline off for 10 days. And there was definitely an impact to the communities, right? Especially if you lived on the East Coast of the United States during that time. So we talk about building OT environments, we want to build them as cyber resilient. So that way, even if the IT network becomes completely compromised and burns down to the ground, that the ICS, the OT environment, continues to function uninterrupted. And then we can also talk about, besides ransomware groups, we also look at other attackers that are looking not only to make a quick buck, but also that we see a rise in hacktivism. So you have hackers out there that for some ideology, right? Typically, they're targeting different environments. So the most recent news was about a group that had targeted and had taken offline the control systems that were responsible for watering the fields out in the Jordan Valley in Israel. And just to kind of put a little final emphasis on the point about the number of attacks increasing over the years. You can see here that over time, we've only had 7 pieces of malware or viruses, if you want, that have been written by nation-state attackers to target control system environments. And you see the very first that we learned of was 2010, was with the revelation of Stuxnet, which when I first heard about, that's what got me interested in control system cybersecurity. And then all the way through, you can see now, just in the last year, we had 2 very significant evolutions of malware targeting OT environments. And so if we've only had 7 over this span of 13-ish years, and then we see we've actually had 2 significant evolutions, if you want, just within the last year. I think it says a lot. And at the same time, the other thing to be concerned with is that while these tools are written by nation states, that eventually the tactics and the techniques that these nation states use, and typically some of this code, gets out on the internet for the rest of the cyber criminals and hackers to use against our environments. So the question is, how do we secure our ICS and our OT environment? So earlier, Ben was talking about and had provided a high-level overview of the critical security controls, which I've been a huge fan of since they were actually initially created by the SANS Institute. And not only does the critical security controls provide a list of 18 different security controls to protect a traditional IT environment, but I always appreciated for the fact that it was well written. It was written in simple terms to help people understand the different controls that you can deploy. That those controls sometimes can be complicated for people to understand, especially if you're new to cybersecurity. And so not only was it a simplified and easy to understand framework, but at the same time, it was a prioritized list, which was the reason I was really drawn to it, because by starting with the first control, you can have the most impact in reducing risk to your environment by applying the first control. And then the idea would be it reduces the second highest amount of risk, and so on and so forth. So you continue working your way down the list as you have time, money, and other resources to allow. Right? So you're not going to be able to just knock out all 20. But you want to be able to move through them as you have resources. And that we need to understand, well, where do we start? So the critical security controls is an incredible resource for securing IT environments, but it's not special, or it's not specific to OT environments. Now, in the OT world, in the control systems world, we have the ISA 62443 standard. And like Ben mentioned earlier, there's a ton of different standards and frameworks you can use for securing IT environments. In the control systems world, we really look to just ISA 62443, right, which gives us a very detailed resource for protecting these OT environments. And while we have the ISA 62443 gold standard, it isn't, again, it's not necessarily easy to decipher at times, right? And it's not prioritized. So you do get a large set of documents that talk about securing the OT environment, but it doesn't help answer the question of where do we start, what do we start with, and that's, I think, what's missing, especially for people that are just trying to get cybersecurity up and running in their control system environments. So the approach I take is, let's take the philosophy of the critical security controls and keeping the information simple, straightforward, and prioritize it to build out this base template on how we can protect OT environments. So here we have a simple to understand prioritized list on where we start, and that we also understand that each OT environment is, like we mentioned earlier, it's its own special snowflake. If I have a nuclear power plant, it has different security needs than a traditional power plant, which has different needs from a petrochemical facility, which has different needs from a refinery, which so on and so on. You get the idea. So the idea is, what does all of this look like? So what we've done is exactly that, in taking the critical security controls, reprioritizing them based on the general needs of OT environments and making them simple to understand, and also provide this idea of a customizable framework that can be tailored and adapted to each unique control systems environment. We've also added 2 controls to specifically call these out for their importance to control system environments, because we did not have conducting risk assessments, which is number 6 on our list, and number 7, secure remote access, is highlighted in the critical security controls for IT environments. And while those are also important on the IT side of the house, they're considered absolute essentials today, especially if you're building a top tier or world-class OT cybersecurity program. And in this list, you can see, and we're going to focus on the top 5 controls today. And then you can see we'll start with secure network architecture. And then on the other end of the spectrum, you have at number 20, email and web browser protection. It's at the bottom of the list because while email and browser protection, it's at the very end, it does exist, and it definitely in the critical controls for IT networks, where we have people browsing the internet with their browsers and they're reading email, right? We shouldn't have employees reading email in control system environments, and they're not using web browsers, or hopefully they're not using web browsers to interact with the internet. They might use a web browser to interact with some type of control system interface, but that's it. So while there is risk there, it's very limited compared to what you would have in an IT environment. So again, we're going to, for today, we're going to cover the first 5 controls, which we consider the basic building blocks of OT cybersecurity programs. 6 through 10 are really then taking your program to the next level, to that top tier, that world-class cybersecurity program for an OT environment. So you'll be substantially ahead of probably the majority of other OT environments that are out there. And we're not saying don't do 6 through 20. We're just starting to say, or really coming to say, we're starting with these first 5 building blocks, and then as resources permit, we continue to build out the rest. So for the rest of the time today, we're going to focus on the first 5 in that I mentioned, those building blocks that we see are the most important. And then again, going back to 11 through 20, you can use those to fill in the remaining gaps in your cybersecurity program over time, and take those opportunities to address different aspects of our different OT environments. So our first control is, we talk about secure network architecture. Right? A significant portion of cyber attacks against OT networks come from the IT network. Right? If we don't have a way for the IT network to communicate with the OT network directly, meaning those connections can't originate from the IT side and move into the OT network, then we've eliminated that risk completely. And that would be great, and ideally, in a perfect world. So each time we do open a path from the IT side to communicate directly with OT, then we introduce a risk with each of those connections. So we want to make sure if we do have those changes, we do them sparingly and only when required by necessary. Because as we open each of those pathways, it's a pathway for an attacker to take, or a piece of malware to take. So you can see here that once the IT network is compromised, that attacker or that piece of malware can easily then move into the OT network. So we want to allow the OT network to communicate directly with the IT network, but not the other way around. If we can help it. So as a quick recap, right, each time we allow a network connection to originate from the IT network to enter the OT network, we introduce risk. We want to eliminate that risk completely if we can from the start. And then we can look at just the OT network as a whole to continue to further segment it down. So that way we're not just segmenting the entire operation between IT and OT, but we're further segmenting to the OT network into additional layers of protection. So we have the Purdue Model, which helps us define different layers in not only IT, but the OT environment. And then we can define how we allow communication to happen between these layers. And so here you have an example of the Purdue Model, which I get really nerdy about at times, because the Purdue model, we actually had a Fluor engineer sit on the initial committee that created the Purdue model, which I find really fascinating and exciting at the same time. But so this might, if you've never seen this before, it might look a little strange at first, but at the top of the diagram at levels 4 and 5, that's actually the IT network, and you can see the internet to represent the cloud. And so we've already talked about reducing or even potentially eliminating the risk between IT and OT by deploying a firewall between the two. It's what we call the enforcement boundary that you see in red. And then we have, so firewalls are devices that allow us to control what type of network traffic is allowed to communicate between the two networks and in which direction. And so if we do have systems that need to communicate between OT and IT, such as if we had a power plant and I want to send process data from inside the power plant to the back office, so they understand, well, how much power are we generating and what resources did we use to generate it? Then we can allow that information to pass through what they call the plant DMZ, which you can see labeled here. And that plant DMZ sits between two firewalls. So we can still effectively allow the data to pass successfully from OT to IT, but help significantly reduce the risk of an attacker taking advantage of the same path and using that to come into and compromise the OT network. So on the next slide, just to mention real quick, so we can look at just the OT network based on the Purdue model. And you can continue to segment each layer into what we've defined as zones and conduits. And this is based off of the ISA 62443 standard. So some organizations just use zones and conduits these days. Some use the Purdue model still. Some use a combination. I would say that's probably the most popular. I think that's the one that we would typically fall to. So it's really about breaking the different systems into logical groupings into what they call zones. So if I have a petrochemical facility, and I'll take all of my safety systems, such as the safety instrumented systems, right? The fail-safe backup we have for that facility to shut down the plant or the facility in the event of an emergency, right? And we can take those and put them into a zone, and we can look at the different systems that it might communicate with. Those would be the conduits, right? So the idea is, in general, that network segmentation is this iterative process that we just continue to go through until we've broken down the entire network down into its simplest collection of systems, right? Logically grouping them together so we can apply those protections to control the flow of traffic, right? Through things like access control lists and firewalls. So we can tightly control this communication, that we ensure that the plant has the communication it needs to stay up and running, right, uninterrupted, but that an attacker, if they are able to get on the network, or if it's a piece of malware, we want to significantly reduce the cyber risk that they present to the environment. So after we talk about number one, right, secure network architecture, we move on to number 2 and 3, which kind of put them together, right? Because it's this idea of having a focus on having a complete asset inventory of all the hardware and software. It also includes firmware in that in OT environments. So the main goal of such a program is to be able to understand that we have what we have, right, in this environment. Because if I don't know what I have, how am I supposed to be able to protect it? If I don't know I have a data historian sitting in that plant DMZ, like we were just talking about, and I need that to provide that process data from the OT network to the IT side of the house, or if I have a HMI, a human management interface that's used to control an industrial process, or a PLC, a programmable logic controller that's used to maybe spins up a turbine in a power plant to help generate electricity. Right? If I don't know I have those things, I can't protect them. So we start with building that asset register or inventory of all the hardware and software and firmware that we have in the environment. So it includes details of, you see, not only the vendor, the specific model of hardware, the specific version of the software and firmware that we have installed in the environment, but also who's responsible for maintaining those components. And that's just to start. Right? And I do understand. I'm very lucky. I'm very spoiled in the fact that the majority of OT environments that I work in are brand new facilities that we're building from literally nothing, from square one. So even then, as we make sure that the asset inventory for a new project is completely 100% accurate, I don't ever want to assume it is that, right? Because people make mistakes, something could be left out. And also, even if the inventory is 100% accurate today, it might not be tomorrow. And what if it's not maybe an employee making a mistake, but maybe it's a malicious insider, or it's an attacker that's put something on the network. Right? So again, even if we have 100% accurate inventory today, it might not be accurate tomorrow. So when we start thinking about some of what actually could happen and what we need to keep an eye out for over time, that really builds into control number 4. So we talk about continuous vulnerability management, which it can't be successful without controls numbers 2 and 3. Right? We need that complete inventory to really get into this conversation on the next slide about having continuous vulnerability management. And so once we have that inventory, or what we want to consider that 100% inventory of all of the assets that we have on the network, right? Then we want to build into the next step. Again, when we talk about with continuous vulnerability management, so the core concept, of continuous vulnerability management is that it's a process that we are continually or always performing. It's always something that's on. In its most basic form, so we use vulnerability management to look at the systems and the software and the firmware that we have deployed that we know about and inform us of any known vulnerabilities with those systems. And so in OT networks, we can do this typically in its most basic form by relying on the asset inventory, which could be in something as simple as Excel. And again, that inventory might or might not be complete. I'm never going to assume that it's 100% accurate, right? Because that could always change tomorrow or the day after that or so on. So we can also look at deploying passive technologies on the network to listen, right, for any new pieces of hardware or software that have been added to the network. And when those new pieces start talking, right, the passive system sits there and it hears that new network chatter and understands, ooh, there's a new piece of hardware, there's maybe some new software on the network that we need to look into, right? Because if a new component is added to the network and it starts to talk, then we'll pick it up and then the system will even ideally identify what type of system or software it actually is. So maybe somebody added a new HMI to the network, right? Or maybe it's someone, and we've had clients see things, everything from home Wi-Fi access points that get connected to OT networks to there was an Xbox one time, and so that the idea is we can have these systems that are connected, and then when we see those new systems, we need to determine, right? Is it an authorized system, like maybe a new PLC from a vendor like Siemens gets connected to the network? We want to pick that up, see exactly what it is right away, and then be able to understand where did it come from, right? Because then if it wasn't authorized, then what do we do, right? Well, let me take a step back before I get too far ahead. And the idea is that in OT environments, right, we want to know the assets we have, and we want to know the vulnerabilities. Because in IT environments, if we have a new vulnerability, the idea is that we typically will run around like chickens with our heads cut off and try to patch all the servers and all the workstations and all the other things in just a couple days or a couple weeks. In OT environments, it's very, very different. Just because there's a vulnerability, it doesn't mean that we need to jump into action right away. So when we discover a new vulnerability, we look at the real risk, the true risk that's associated with that vulnerability to determine if it needs to be addressed. If I have a control system like a PLC that's very embedded deep within the OT network that has very little to almost no visibility from an attacker to be able to interact with it, right? Do we need to fix it? Right? And at the same time, if we need to take the facility offline for, let's say, 24 hours to be able to address that vulnerability, and we know that there's no risk to physical harm, right? The on-site personnel, there's no risk to the environment, there's no risk for or potential for loss of life and no loss for production from that vulnerability, then why would we address it? So it's very different in OT networks when we talk about vulnerability management. But I did want to circle back on one of the important aspects of continuous vulnerability management, and that we're, again, always looking for new assets to be added to the network. So that way, when we determine that new asset is there, we find it and we need to determine what it is, right? And if it's authorized. So if it's something like a new engineering workstation, a data historian, an HMI, something that's supposed to be there, maybe it just slipped through the change control process, then we need to make sure that we get it back into the change control process and add it to the register and the asset register, and we know about it and we can protect it moving forward. If it's not an authorized system, then we need to initiate our incident response procedures to understand where did it come from, right? What's the purpose and how should we respond? We need to make sure that there are no risks that we were talking about earlier with the physical aspect of making sure on-site personnel don't come to harm, that they can go home at the end of their shift. Right? We want to make sure there's no impact to the environment and make sure the facility is up and running. And lastly, we just want to make sure for those environments that they don't have, for environments that don't have existing vulnerability management programs in place today, right? And if you don't have the necessary skill set to deploy one, and that's okay. Most don't, because it's a fairly new concept to OT environments. You can go out and engage with an outside provider. And there's a couple of big shops and some boutique firms out there that can help you build that program. And one last thing to talk about in continuous vulnerability management is this idea of we're always looking for systems that we have on the OT network that are exposed to the internet. And this is another one of those routes or vectors that attackers can use to get into our OT networks. And so here's a couple of examples that I wanted to look for. And we mentioned, Jared, with the internet, right? We have that connectivity to everyone, and everyone has that connectivity to us. So in the first example you see, and I used a site called Shodan.io. And if you're not familiar with Shodan.io, Shodan's a search engine, kind of like Google is for websites, but Shodan can index other things like control systems and CCTV cameras, which are connected to control system or OT networks, which to me essentially makes them control systems if they're on the OT network. So in the first example we have is, so if I have someone deploy a CCTV camera like we see here, right? And maybe somebody wants to watch this facility as it's getting built. Right? The idea is it's connected potentially to the OT network, and now an attacker can see it. And that camera is just another system running Windows or Linux, and it's typically going to be very easy to exploit. And now the attacker has a foothold on the network. And then the next example you can see, here's another industrial site, or maybe it's a construction site. Right here you can see a lab, right? Laboratory. I call this the front of the house, thinking in restaurant terms, because then they had another camera you could see, and there's the back of the house. So again, the main concern is not that we just have these environments that have video streams exposed to the internet, but the cameras themselves can be compromised by attackers to give them a foothold on the OT network. And then lastly, real quickly, you can see here's a great example of a simple control system that has a web-driven interface exposed to the internet. It's for a well. And I found it interesting because I found it in probably less than a minute on Shodan, and that I couldn't figure out what they were trying to do with the clouds. If that was supposed to be clouds, but they were brown, and it came across as a toxic cloud. I wasn't really sure where they were going. It's very ominous looking, but it's a good example here, an actual control system that's exposed to the internet, and that everybody on the internet can actually reach out and touch it, and an attacker could take control over it and have that foothold. So then, as we move from continuous vulnerability management, we talk about number 5, which is incident response planning, right, and management. Right? What do we do, right, to prepare for that cybersecurity incident in the OT environment? Because like on the IT side of the house, we always say it's not a question of if, but it's a question of when. If you don't have an incident today, well, it's going to be tomorrow, or if not tomorrow, it's next week or next month or next year, or so on and so on. It's coming. It's just a matter of time. So we have to make sure that we develop and we prepare an incident response plan by involving the individual that are going to be, part of responding to an actual incident, right? Work with those folks to understand, right, the processes that they're going to follow, right? And not just the IT folks on the IT side of the house, but all of the appropriate OT folks as well, the engineers, right, the plant operators, the folks that are doing the operations and maintenance work, right? Make sure you have those key contacts. So when an incident does occur, you're not running around like the chicken with your head cut off, right? And you have that plan you can follow. And we have to keep in mind, remember that each OT environment's different, right? So we have to tailor the incident response program to the specific needs of those environments. And so not only do we include our own team members, but we can also have folks from non-technical aspects like HR, legal, corporate communications, which will our term. And then we look at maybe we also need to understand, not maybe, but we do need to understand when we need to go out and have a outside incident response firm come help us. Right? And we need that help to truly understand what's going on. So on the next slide, we can look at, and just to wrap up, right, we can look at, the idea is the ultimate goal of incident response is to contain the incident and eradicate it, resolve it in the shortest amount of time possible. Right? If we find that we have an attacker in the environment, we want to prevent them from having further access to the environment, and ultimately remove them and prevent them from coming back. The quicker we can remediate the issue, the incident, right, the less time the attacker has to do damage to the facility, and we can reduce the overall impact, right? And it prevents harm to on-site, the chance of harm coming to on-site personnel, right? Going back to the harm to the environment and losing the actual facility's production. And so of course, if the integrity of the facility or particular systems are at question at any time, and it would impact any of those, then we would shut down the facility. We need to understand how we shut down that facility very quickly, but safely, right? If safety is ever a concern, so we make sure that the primary considerations for preventing physical harm coming, especially to on-site personnel, is enforced. So that brings us to the end of the conversation. So where we covered this idea that we have OT environments such as power plants and refineries and this wonderful list that goes on, right? It's very different from traditional IT office networks, right? In order to protect OT networks, so we've taken the approach, I've taken this simplified approach by taking the idea of the critical security controls, right, from taking that adapting its prioritized approach and using it for OT environments. Right? And keeping in mind that each OT network is its own special snowflake, and right, each has completely different physics. And so we have to look at them from that engineering perspective and understand how we secure those individual specific environments. So hopefully, I hope this helps, and want to thank everybody for the time today and taking the time to come to the session, and we'll open it up for questions.
All right, thank you, Mike. So as Mike said, we're going to take some time to address questions that we've received. And if you'd like to ask a question, please post it in the Q&A panel and address it to all panelists. So the first question, Michael, is How can scanning tools inventory assets for the large number of ICS sites? And can active scanning break ICS operation?
So it's a great question. And to take it at a high level, and we could always circle back that that's where we were mentioning with continuous vulnerability management in OT networks, we're really looking at doing this with passive scanning because there is a concern with active scanning that could impact, especially older control systems and take them offline. So we do deploy different sensors to listen to the network passively, like going into a room filled with people and you just stand in the corner and listen and wait for somebody to say something. With active scanning, you basically go into that room and yell at the top of your lungs and look to and wait for people to respond. And while that works in IT environments, it's not necessarily what we want to do in OT environments, and it could impact those systems. So we do want to make sure that we do deploy passive listening systems in OT environments and make sure we deploy it so we have complete coverage, or what maybe that environment determines is what it specifically needs for coverage. But again, it's a great question. It's one we probably dig deeper into, and maybe as a follow-up after the session.
Sounds perfect. All right, another question. So regarding zero trust, how can it be implemented in ISA 62443?
That's another great question. It's also another tricky one. It probably takes 100 hours to answer. But another one at high level, and we can circle back, is with zero trust, a lot of environments, whether it's in IT or even OT these days, talk about the road or the path to zero trust, and understanding that every system on the network is identified and it's known and it's proven its identity. And then we control the traffic like we were talking in network segmentation. So from our approach, we're basically building that path to zero trust. And as you go through those other controls, that you can start to fill in those gaps, just like you would see in an IT environment, just of course done differently for OT. So the way, again, we've done the critical security controls, it helps you on that path to zero trust, which is kind of that nirvana that everybody is trying to get to. Very few environments will ever get there, but it's definitely a road that everybody should pursue. A great question. We'll definitely circle back on that one.
Thank you. And next question. Are there special considerations for using managed services for OT and ICS environments?
Another great question, and I appreciate that one because it speaks to, when we're looking at our list of critical security controls for OT and networks, you can see number 7, which is secure remote access, which I think is really key to securing OT networks. Because if you're going to have an outside provider like an MSP, or maybe it's a OT vendor that's going to do maintenance remotely on one of your systems, right? They're going to need that access into your network. And so you need to make sure that that's done securely, that it's architected appropriately. You use things like multi-factor authentication. I always suggest people disable accounts when they're not in use. I always get a lot of pushback on that one because it definitely takes an additional step for an administrator to open up that account, right, and disable it once the work has been done. But it's another way we can lower the risk associated with securing remote access, because remote access is another one of those ways attackers can slip into the OT environment by either taking control over that remote access equipment, or if they've stolen credentials and you're not using things like multi-factor authentication, or maybe you're even using multi-factor authentication, but you're not disabling the accounts when not in use, and you're not watching the event logs for that system to see who's logging in and from where. So again, it's another great question. It's another one I could probably spend 40 hours talking about, and another one I'd love to follow up but I think one of the main focuses is really on securing remote access into these environments.
All right. Thank you. So some IT people believe vulnerability scanners have a lot of false positives and tend to cause issues with ICS equipment. How do you get started with vulnerability scanning?
No, it's a great question. I think we touched a little bit on it. One of the earlier questions. The idea we want to make sure we use passive listening scanners. They say I hate the word scanners because we're not at that point scanning anything, right? We're listening to the network. The question comes up a lot about false positives. I would say the false positive rate for these types of systems, while they are very substantial, I would say in quotes back in the day, the percentage of false positives that we see today is at least from my perspective and what we see in our environments is very extremely small, to where it's very rare to actually see them. So when we have a vulnerability finding, we take it as it's a real true finding. And every once in a while we work with a vendor to find out it's a false positive, and that's okay. But we take every finding as truth and work on the assumption that's a real vulnerability, and then look to determine, is this something that we go through that risk assessment process? Is this something we need to address in this one specific OT environment or not? Again, it's another one would love to follow up on and with some additional details.
All right. As a follow-on to that, is there a specific tool that you use for vulnerability management in the ICS environment?
Yeah, there's a couple of great providers out there. At Fluor, we're a big Tenable shop. So they're a large provider. I've used their product Nessus since it was really the very first vulnerability scanner that was, I guess, commonplace back in the day, 20 years ago, in IT networks. And then they had, a couple years ago, purchased a company that had focused specifically on OT. And there's other providers out there as well, and we could put together a list of a couple of the common providers. We typically will talk and have relationships and work with just about all the providers out there. It's not a very long list, but there's definitely some great companies to work with. Our most experience, though, is with the Tenable platform.
Thank you. A quick question. For the critical security controls, is that a framework or a standard like the ICE 62443? And where can that be found?
Oh, good question. And so the critical security controls is now hosted by a group called the Center for Internet Security. So I believe it's CIS.org. Or you can Google for it just to make sure you don't go to a malicious site that I just gave you a name for. But the Center for Internet Security now hosts the critical security controls that it took over from the SANS Institute. You have to sign up for an account to log into the website to be able to download it. But once you have the account, you're able to download it, and they have a lot of other great resources like templates for securing all of your different systems, especially with the main focus on IT environments, so Windows servers and Linux servers and Cisco routers and switches. But a lot of those can also apply on the OT side of the house. So I don't want to overlook that. So there's a lot of great resources there as well. But yeah, the critical security controls is a framework that some people might refer to it as a standard that you can use to help guide how you secure your network. Hopefully that answers the question.
Yes, I think that is very helpful. So, all right. And I've seen a comment or two about some members of our audience. They weren't aware that Fluor was involved with cybersecurity of our client organizations. So, Michael, how can they get in touch with you to learn more about Fluor's capabilities in this area?
Sure. I appreciate all the great questions. So probably the maybe the easiest thing is to reach out to me directly. So you can find me on LinkedIn. You can email me at michael.holcomb@fluor.com. But LinkedIn's a great option to reach out, and I can make sure to get you in contact with the right person depending on where you work, the industry you work on. But Fluor does a lot of work with our clients. Some clients have very well-established cybersecurity programs, so we work with them to a smaller degree. We have other clients on the other end of the spectrum that don't necessarily have a cybersecurity program built out, or they don't have those resources. So, we'd love to be able to work with them and help them in that case. And then I would say most of our clients fall somewhere in between the two, right? They have at least some level of cybersecurity program, but maybe don't have all the resources or expertise that they need for their environment. And so I'd love to work with them on that, especially when it comes, at least for me, when it comes to the OT networks.
Well, thank you, Mike. And so it looks like that's all the time we have for questions. Thank you, Mike and Ben, for this informative webinar and the time you've spent both today as well as in preparation. So thank you to our audience for attending. It's been a pleasure being your moderator. So please continue to stay informed of these events by visiting the Innovation Builders page on fluor.com or following our social media channels using #InnovationBuilders. If you'd like us to send you an email notification of future webinars, please email us at innovation.builders@fluor.com with opt-in in the subject line. From all of us on the Innovation Builders team, have a safe day.